All right, we're going to start a lesson on percents, and it's probably something you're fairly familiar with because you're always using them. You say, well, 50% of the time, meaning half of the time, or you say, I am all for that. I am 100% for it. So we use those terms, but sometimes when it comes down to the math, we're not quite sure how to convert a situation like, well, I got 2 out of 3 of them. I wonder what percent that is. So let's look at how to convert something that's a fraction to something that's a decimal, well, you are going to have decimals, something that's a percentage, and vice versa, from a percentage back into a fraction. And that fraction, of course, could be a ratio. Let's draw it out first. All right, so first of all, we're going to, let's pick a situation. Let's say we've got, I don't know, 35% of the kids in the class. What did they do? I don't know. Well, think of something. They, got an A+ on their test. Wouldn't that be cool? When I feel like I have really accomplished something. What does that look like? Well, I'm coloring in this 10 by 10 chart, which we call a hundreds chart or a 10 by 10, because that represents the whole thing. And I want to know what 35% looks like. Well, I just colored in one row or one column, and there's 10 in each, 10 little blocks in each one column. So that would be 10%. Well, I want 30%. I want 35%. So let's keep coloring. And there's 20%. And here's another one. There's 30%. And of course, we need 5 more to make 35%. All right, so that's how it would look. This would be written as 35%. But it could also be written as a fraction, and that's out of 100. It's 35 little blocks out of 100 possible blocks. Is that a ratio? You betcha. It's a ratio of the part that I have to the whole that I could have. So I am comparing two things. I'm saying for every 35 that I have, there is 100 that I could have. Let's draw out another one, and this time I'm actually going to change it up a little bit. What if I was describing a situation where if I say it happens all the time, well, that doesn't always mean it happens all the time. You could say to your friend, you say that all the time. Well, no, they don't. They eat dinner, they go to school, they do all sorts of other things other than say that. So saying it all the time doesn't really mean all of the time. But what if you want to say that normally they say it a lot, and we'll call that 100%. This is what they normally say. So all of what they normally say, we're going to represent as 100%. So let's say they say the phrase, oh my gosh, which is way overused. But anyway, so they say this very regularly, and it's almost predictable. So we're going to call that, for them, it's 100%. Okay? And every day it's just about the same thing. It's pretty predictable when they're going to say it, when they're not. Now, what if, for some reason, they changed and they actually increased it? We could describe that as they could double it. They could do it twice as much. And if that's the case, I'd have to have another box over here. And I have to color the whole thing in. And I would use a percentage of 200%. Now that seems kind of weird, doesn't it? But think about this. What if you said to your friend, you know, you're saying, oh my gosh, twice as many times as you used to. Twice as many. Double. Well, double is 200%. So percentages can be greater than 100 if you define them correctly. So you always have to use words to define what are you really talking about when you mean is 100%. Does that mean it can never ever be more than that? When you think of 100% as all, everything. Well, sometimes it's not all everything, but it's all of what we're thinking about, such as the amount of times my friend says, oh my gosh. So you will be doing some practice with percentages greater than 100%, which means it's more than you're normally used to. It doubles or triples. All right, let's look at some other ways to do this. Now, we're converting percentages to fractions and fractions to percentages, but why do we write it that way? Well, this little symbol, percentage, actually is a number. I don't know if you recognize that, but it is the number 100. Don't look like the number 100. Well, if I took this 0 here, and I put it down here, and if I took this 0 here, and I put it down a little bit farther, and if I took this 1 here, and I put it in between diagonally, I'd have the number 100. It actually is another way of saying 100. So out of 100. Out of 100. So that's the meaning of this symbol here. It means out of 100. All right, now that we know that, we're going to take a common ratio and we'll make it easy. Remember I said we can use Windex, and it's a ratio of 1 part of concentrate to 4 parts of water. Well, obviously that's not a percentage, it's a fraction. It's a 1 to 4 ratio, or it could also be 1 part out of 4 wholes instead of a 1 to 4 ratio, 1 out of 4th, 1/4. Or I could say, well, that's something out of 100. So I have to ask myself, oh, look I could cross multiply and divide. Oh my goodness, I've got 2 fractions here. 1 times 100 divided by 4. 100 divided by 4 is, you got it, 25. So see how those equivalent fractions keep coming up every lesson? All right, so if I have 25 out of 100, I am going to say that that is the same as 25 divided by 100. If I divide 25 by 100, I find that 100 goes in, and that's going to look like this if you were doing it the long way. 100 goes into 25. Well, it doesn't go into 25, does it? So it goes in 0 times. So I'm going to add a 0. Well, it does go into 250. It goes in 250 twice, with 50 left over. And if I carry down another invisible 0, it goes into 500 5 times. There's my 25. So as you can see, it is the same as 0.25. Now this one you've memorized because we use it all the time. But what if I gave you a fraction like 6/7? You wouldn't be able to do that in your head. Or what if I said it's 17 out of 18? or 13 out of 28. So then you'd have to do some math. So I want you to get this process down. So I go from a fraction to another fraction that is over the denominator of 100. I change that into a decimal, and then I take my decimal, 0.25, and I simply, because now I already have this idea of 100 there, this is 25 out of 100, I'm simply going to move my decimal place, the number of zeros, I've got a 0 here and a 0 here, 2 zeros over, so I now have 25%. 25% is the same as 25 over 100, which is the same as 1/4. Those are ones you should just memorize. It's the others that you're going to need to do this math on. Let's look at the opposite way. This time I have a percentage, and let's use 3/4. Here's another one you should memorize, but 3/4 is 75%. Well, let's prove that. So 75%, and as you remember, we have these 2 zeros. Okay, so we have 2 places here. So there's the 7 and there's the 5 in my decimal. So there's the same. Now watch out. If I gave you 7%, it does not equal 0.7. Okay, watch out. 7% equals 0.07. There's always 2 spaces that have to get filled up. You fill in the smaller amount first. So it has, this is over here, 5 is 5/10. So that's the smaller amount. The 7 is the larger amount. 7/10, excuse me, I said that wrong. 5 ones is the smaller amount and 7/10 is the larger amount. So make sure that when you only have ones, so like 7%, I have 7 ones, 7%, that I don't express that as 0.7 because that would be the same as 70%, not 7. All right, so here we go. We have our 0.75, and now we're going to convert that to a fraction over 100. And then we're going to take that fraction over 100, and we're going to reduce it. So what number goes into both of these? Well, 25 goes into both of these. 25 goes into 75 3 times, 25 goes into 100 4 times. So as you can see, 75% and 3/4 are identical. Those are ones you want to memorize. You don't have to do the math on half, quarter, 3/4, even 1/3 and 2/3 you should memorize. But all those others, you're going to have to go through this process. So we'll practice that tomorrow.